So our research here at MIT focuses on both the development and experimental realization of what I like to call nanosystems. So what is a nanosystem? Well, a nanosystem is when we take new emerging nanotechnologies. These enable new types of devices, like new transistors, new types of memory cells, maybe new types of sensors, etc. And building a nanosystem asks the question, well, just having a better transistor, a better memory cell gives me a little bit of benefits. But how can I combine all these benefits all together in order to realize new types of systems, which in the end can enable brand new types of applications? And the types of applications that we're looking at currently here in our group range from both traditional high-performance computing applications, and these are how do I make a computer run faster, how do I make my cell phone battery last 10 times longer, to applications that extend beyond the scope of what we would think a typical electronic system would do. Because electronics are not just contained to building better computers or better cell phones. So for instance, if we can build systems which have sensors and memory and computation all intertwined, all densely integrated in three-dimensional stacks, for instance, what types of medical applications for point-of-care diagnostic care could we perform? So ILP has been a tremendous asset for myself here at MIT, forming the connections between the research that we're doing in our group and different member companies that come and visit, and those conversations that we have already themselves not just created contacts, but they've also created brand new research projects. Because we have our ideas of what we find interesting, and we're constantly looking for new applications where we can apply the research in our group to. So all the time we're meeting with different companies that come in, and they have a very different set of problems, a very different set of applications that they're interested in, and it's exciting for us because not only does it make our work that much more broad, but we learn a lot from meeting with these companies. What are the important problems to ask? What are the different applications we can apply our research to? One of the many emerging technologies that we focus on are carbon nanotubes. And I think they're an excellent case study for the type of work that we try and do, because we don't, while we focus on asking the question, how do we make a really improved device using nanotubes? What I think is really exciting is what are the new types of systems that we can build using this new underlying technology. And recently, there's been, for many, many years, no one could build any type of system using nanotubes. And certainly, if you could build any type of very, very small scale circuit, it would be very, very low performance, and the devices would also not achieve the performance that's promised. And recently, I think we've made, both myself and collaborators and the whole community, this whole field, has made huge advancements, specifically with carbon nanotubes. And have shown devices that can compete against state-of-the-art silicon. We've been able to build systems now that have millions of these devices on them. And I think it really shows that after all these years, the work that so many researchers have put into the field is starting to become fruitful. And what it allows us to do now is we can go beyond asking these very nitty-gritty, very device-level questions, and can actually start building some really exciting chips and systems with these new technologies. And what's exciting is we can go, because we can actually build systems using these new technologies, we can really ask the question of what can these new technologies do beyond just make a better computer, right? What new types of systems can we actually build? For instance, if we can build and we are building systems that have millions and billions of sensors built directly onto the chips, what types of medical applications could those do for point-of-care diagnostics from your breath? If you can make a chip that's extremely, extremely small and you can put that inside of the body, what could that do? If you could use nanotechnology and not even have a chip, but just put nanotechnologies inside of your bloodstream and monitor them in real time and where they're going and what they're doing inside your body, and what could you do with that?